This is worksheet 3 of the Covalent Compounds packet. We've now talked about how to name covalent compounds, and we've talked about some properties of covalent compounds. So now we are going to represent these compounds. So when two nonmetals bond to each other, what forms the bond is not an attraction between positive and negative charges, like with an ionic bond, but instead sharing valence electrons in the outermost shell, is what forms this covalent bond. So I think of these as sort of friendlier bonds. We're not stealing electrons or giving electrons away completely. Instead, they're being shared. And so once these two atoms are sharing electrons, the electrons stay in between the two of them, and therefore it forms a connection between these two atoms. Right? If you're sharing a calculator with somebody, it works out a whole lot better if you sit next to each other than if you sit on two opposite sides of the room. And so necessarily there's this sort of location connection between the two people who are sharing. Well, same for these atoms. So it's important to keep in mind as we start drawing these bonds, the goal that we've talked about before, which is for every atom to have 8 electrons, with the exception of hydrogen and also helium, but it's a noble gas, so it doesn't play with others, so for our purposes, just hydrogen. Remember, it's just going to have 2 electrons to fill its shell. So that means that hydrogen, the little bitty one that can only have 2 electrons, can just form a single bond, a shared pair of electrons, and all the other atoms can form up to 4 single bonds. All right. A couple of hints. When you draw these diagrams, you're going to want to start with the atom that there's only one of in the formula. Put it right in the center and connect the other atoms around it. And if there are 2 atoms, only 2 atoms, then it doesn't really matter where you start. You just plop them down and form connections between them. Alright? Okay, so there's some other hints here you might want to read through, but let's go ahead and get started with an example. Alright? The very first thing that you must do when drawing these covalent bonds, and sometimes people try to skip this step and it really never works out well for them, is you need to count up how many valence electrons you have to work with total. What do I mean by that? Okay, well, if we have nitrogen triiodide here, nitrogen is in the 5th family of the periodic table, so it has 5 valence electrons, right? It's in that 5th column. And each iodine is going to have 7 valence electrons because iodine is in the 7th family, or the 7th column of the periodic table. So I'm going to take that 7 and I'm going to multiply it by 3. Why? Because I've got 3 iodines. They each have 7 valence electrons. So 7 times 3 is 21 plus 5 means I have a total of 26 valence electrons to work with here. Those are the ones that can be shared. Alright? Now, remember we said that you start with the atom that's only in the formula once. So here's nitrogen. Alright, and nitrogen has 5 valence electrons, but I'm not going to draw those in right now. Okay, instead what I'm going to do is I'm going to draw the 3 iodines around it. And I'm going to draw them connected to the nitrogen by a line. Now, what does this line represent? This line represents a shared pair of valence electrons. So these are 2 electrons, one that originally belonged to nitrogen, one that originally belonged to iodine, and nitrogen and iodine have agreed to share them. So now both of the electrons belong to nitrogen, but both of the electrons also belong to iodine, and they sit right in between the 2 atoms. So it's really important to remember that this line here equals a total of 2 electrons. If you count it as 1 electron, your whole electron count is going to be off. Alright, that means so far then I've used 2, 4, 6 electrons total just connecting the nitrogens and the iodines. So if I subtract 6, that means that I'm left with 20 electrons. The next thing I need to do is finish filling the shell of my central atom. Nitrogen's my central atom, it's right in the middle. Right now it's got 2, 4, 6 electrons around it. It wants 8, so I'm going to put 2 more electrons up here. Okay? These dots each represent just one electron. And while the line represented 2 electrons that were shared, these single dots represent 1 electron that belongs just to that atom. So these electrons up here, oops, 1, 2, right, they just belong to nitrogen. So that means I've used 2 more electrons, which means I have 18 electrons left. Now that my central atom has all 8 electrons that it wants, the next thing I'm going to do is start spreading my electrons evenly around my outer atoms. So in this case, that would be the iodines. So I'm going to put 2, 4, 6, 8, 10, 12, 14, 16, 18, right? I always put the electrons in pairs of 2, and I keep spreading them around as evenly as I can among all of the atoms. Now, in this case, it worked out really well because once I've used up those 18 electrons that I had left, I've managed to put 8 electrons around each of the iodines, right? Here's 2, 3, 4, 5, 6, 7, 8. Same for the other ones, right? Remember that line represents 2 electrons. Okay, and this is when I stop. Here's another problem that students run into. Remember that you only had a total of 26 electrons to work with total. 5 from the nitrogen and 7 from each of the iodines. Once you've used up all the electrons, you can't keep going because you can't just magically create new electrons that you didn't have to begin with. Okay? So, this right here actually is your final answer. Alright, some of you who work in pen want to try to kind of make a rough draft of your answer to the left, and then you can just rewrite it here. Okay, if you're working in pencil, you could start your drawing right in the final answer spot. Oops. So you want to make sure you get all your dots. And that's your final answer. Okay? I want to do maybe one more that's sometimes tricky for people, so let's go down a little bit to hydrogen. Okay, hydrogen's always sort of weird because it's kind of the exception. Okay, so we're drawing hydrogen here. Hydrogen is 2 hydrogen atoms bonded together. Makes a gas molecule, as it turns out. Not important to us here. But what is important is that, remember, each hydrogen represents just 1 valence electron. It's in that very first family of the periodic table. So, to total up my valence electrons, each hydrogen has 1. I've got 2 hydrogens, right? That's what the little subscript means. So I just have 2 electrons to work with. How weird. The other weird thing is that I have no central atom. That's obvious because there's no atom that I have just 1 of. All I have are 2 hydrogens. So in that case, I'm just going to plot my 2 hydrogens down, and I'm going to connect them with a bond. Right? Now let's think about this. How many valence electrons does that bond represent? It represents 2. Yeah? So I have just used up the 2 valence electrons that I have. Now, lucky for me, hydrogen only needs 2 electrons to fill its shell. So this hydrogen right here, it's got 2 electrons, the ones that are shared in the bond. This hydrogen here, it's also got 2 electrons, the ones that are shared in the bond. There you go. That's the end of the story. This is a good lesson because hydrogens, since they can only hold 2 electrons, once they form a single bond, that one line, they're done. Once they form that line, they shouldn't have any extra single dot electrons around them because their shell can't hold any more than just the 2 shared electrons that are held in that bond. Okay? So you can take a look at the others, and we will continue working on this when you get to class.